This video demonstrates a drive-by download prevention mechanism that was developed by the NECMA project. First of all, we will discuss the background of the problem. As you know, drive-by download attacks are currently a serious problem for Internet users. Let's look at the mechanism of this type of attack in detail. In this example, an attacker hacks a legitimate web server and inserts code in the web service that redirects user access to a download server which hosts malicious software. The user's browser downloads that malicious software, which then proceeds to crack the user host. In this attack, obfuscated JavaScript codes are used for the redirection. Obfuscation techniques in and of themselves are not illegal, but attackers' malicious usage of such techniques is illegal. The main purpose of obfuscation is to hide source code knowledge from others. However, attackers use the obfuscation to keep the malicious code hidden from the security software of users' hosts. If there is no obfuscation for the redirection, the security software easily discovers the bad code by referencing domain-based blacklists. Our proposed mechanism focuses on the code obfuscation and unobfuscation. The mechanism classifies web pages by analyzing the web page codes before rendering those pages on the user's web browser. We implemented this mechanism as a Chrome extension. The extension works according to the following sequence. Through its analysis, the extension lists up domains that are written in the unobfuscated codes. The next step is rendering those codes on the user's browser. Obfuscated JavaScript codes are executed during this step. If the codes contain any redirections to download servers, accesses to the server's domain will be generated. The mechanism then observes those accesses and cross-references the accessed domain with the domain lists analyzed previously. If the accessed domain is found on the list, the access is approved. If not, the access is terminated by the mechanism. In this way, our mechanism can block redirections to download sites caused by obfuscated JavaScript codes. If the Chrome extension is activated, obfuscated redirection is blocked. Next, we will show a demonstration of the extension, and you can see how it works on an actual environment. First, we will demonstrate the accessing of a legitimate website while using the extension in Chrome. For this example, we will access yahoo.com as the legitimate site. Of course, accessing this legitimate site using our Chrome extension will be the same as when users do the same thing with a normal Chrome browser. In other words, even though our extension is in fact working on the browser, there is no critical latency affecting the browsing. Second, we will demonstrate the access of a malicious website. We created a fake site with malicious codes called poipol.com, which is a fake version of paypal.com. When accessing the poipol.com, the browser immediately shows alert messages with dog photos and sounds. Next, among the user accesses of the fake website, we will compare two groups: those who accessed the site with the extension and those without the extension. At this time, the left side browser is using our extension. Conversely, the browser on the right-hand side is not using our extension. When both browsers access poipol.com, the right side window, which is not using our extension, has no alerts. The website design is almost exactly the same as the legitimate PayPal website. However, we can easily recognize the suspicious nature of the website on the left side browser because of the visible alerts and barks. We also tested our implementation on a tablet PC. Let's take a look at the demo. This demo also accesses the fake PayPal website. The extension has been shown to work sufficiently in an actual environment. This result shows that even if the display size is constrained on tablets or smartphones, the proposed mechanism will work and effectively displays alerts to the users. We evaluated additional latency caused by our mechanism. In this experiment, we measured the latency when browsing websites with and without the extension. We acquired the top 100 popular websites ranked by Alexa. We accessed each website and measured the total rendering time with and without the extension. Finally, we calculate latency of the mechanism from the measurement results. This graph shows the rendering time on the browser. The blue bar denotes cases in which the extension is disabled. The orange bar denotes cases in which the extension is enabled. The average rendering time in the case of the disabled extension is 0.74 seconds. On the other hand, in the cases where the extension is enabled, average rendering time was 2.2 seconds. The delay caused by our extension is only a mere 1.46 seconds. We think that such a small delay will not affect user experience on web browsing. Thank you very much for your attention.